How are you all doing? সবাই ভালো আছেন তো? সালাম আলাইকুম. Everybody is doing good. Thank you. We will start our discussion on sampling distribution and sample size. So let me first draw a bell-shaped normal distribution. So a normal distribution is bell-shaped. So on the horizontal axis you have x. X is a random variable like say height, weight, something. Whatever we are measuring on the horizontal axis. Okay? And you have a bell-shaped curve. So it looks like this. At the center, where the peak is the highest, center is mean. And the shape of this curve is given by standard deviation sigma. Okay? So mu is mean, where the relative frequency is highest, sigma is standard deviation. What is standard deviation, you ask? It is an average variation from the mean, that is on the right of the mean, left of the mean, an average variation of a number in the distribution, in this distribution from the mean. So what do we have on the vertical axis? We have probability or relative frequency. This is also called probability density function. This curve is also called PDF, probability density function. And in this case it's bell-shaped or normal density function, because probability is measured on the vertical axis and the random variable what we are measuring is on the horizontal axis. What is a random variable? A variable that can take different values depending on the particular subject in the measurement, such as height, weight. Now this is a regular normal distribution. When we converted this x to a normal variable, the curve looks very similar. Only difference is on the horizontal axis we have z on the horizontal axis. Now this z curve has a peak at the center. Its mu is equal to 0. Okay, and sigma is equal to 1. This is a z curve or standard normal curve or standard normal curve. Again, probability on the vertical axis. So you are asking me what is z? Z is the standard normal variable, and the definition of z is given by, so from x curve, from x on the horizontal axis you are going to z. Z is a standard normal variable. Z is defined as how far, suppose you pick up a number here x, how far the number x is located away from the mean. So the numerator is deviation from the mean or difference from the mean. How far a particular number is different or away from the mean, divided by standard deviation of the curve. This is called a standard normal variable z because it is divided, because we are dividing the deviation by the standard deviation. Deviation from the mean by the standard deviation, dividing by the standard deviation. Hence it is called standard normal curve. Okay, so z is how many z, the number z measures how many standard deviation the number x is away from the mean. The number x is away from the mean. X is away from the mean. Okay. So at the center, I said this is 0. So at the center, the mean is 0. Why the mean is 0? Because at the center it is the mean, because it's a bell-shaped curve where the relative frequency is highest, that is the mean. So for instead of x, if you substitute mu, because at the center this is the peak, this is where the mean is, mu minus mu is 0 divided by sigma is 0. So at the center the mean is 0 and sigma is 1. Okay, sigma is 1. Okay, so Z measures how many standard deviations you are away from the mean. Now you have positive values, positive Z on the right of 0 and negative Z on the left of 0. On the left of 0 because these are at the center. Okay. So if you get a Z score of 1 means the number x, whatever its value, number x is located one standard deviation STD period deviation DEV period away from the mean. Now positive Z, as I've shown here, positive Z means you're on the right of the mean, negative Z means you're on the left of the mean. Okay, so basically z-score tells us how many standard deviation you are away from the mean. Positive Z means you are on the right of the mean or greater than the mean. Negative Z means you are on the left of the mean or less than the mean. Now let's apply this same concept to the sampling distribution. Sampling distribution of sample means. This is nothing but the probability distribution of sample means. So on the on the horizontal axis, since this is the probability distribution of sample means, which is x bar, okay, you have x bar on the horizontal axis. Okay, instead of x you have x bar. So you are collecting samples of the same size, simple random sample of the same size, say n equal to 30 different samples. They have different values of the sample means, and you are doing a probability distribution of x bar. This is also bell-shaped. Okay, at the center where the peak is the highest or relative frequency is highest. Okay, this is your mu x bar, the center where the relative frequency is highest. Okay, so again on the vertical axis, remember we have probability. So probability of the mean is the highest. Now from central limit theorem, mu x bar, that is the center of this distribution, is equal to mu, which is mean of the population, that is mean of this curve. So what does it mean? It means the relative frequency or probability is highest for the sampling distribution at the center where the value is equal to the mean of the population. How about the spread of this sampling distribution of sample means? This is given by sigma x bar is equal to sigma divided by square root of n. Okay, so this is the standard deviation of sampling distribution. Okay, this is also called sigma x bar, is also called standard error of the mean. Standard error of the mean. . So the center is located at the mean of the population, but the spread of this curve or the standard deviation of the sampling distribution is equal to standard deviation of the population divided by square root of n. Now suppose we want to find the confidence interval for the population mean. Okay, so again we draw a bell-shaped Z curve. So again we are dealing with the sampling distribution. Okay, which is the probability distribution of x bar, but converted to standard normal distribution. Or Z curve, this one, Z curve. Okay, this is also bell shaped. Only difference is at the center Z is equal to 0. Okay, and sigma is 1, but suppose we are dealing with the sampling distribution of Z curve. Okay, so suppose we want to be have 95% confidence in the confidence interval. Okay, that means the area confidence interval Z is 0. Also we know from the sampling distribution the center where the peak is the highest is equal to the mean of the population, and standard deviation of the sampling distribution is given by this. Okay, so 95% confidence means from the center we will basically draw two vertical lines such that the area between these two vertical lines is 95% or 0.95. You know the total area under a standard normal curve is 1. Any normal distribution total area is 1. You ask me why? This is because the sum of the probabilities is always 1. So we locate the two boundaries such that the area under the normal curve is 0.95 because we want to be 95% confident. So that means our population mean will be located in only in most probably in this area. So if we do 1 minus 0.95, this is equal to 0.05. Okay, this is area in the two tails. Two tails mean two edges, this tail and this tail. Area in two tails. Now we all know normal curves are symmetric. So area in each tail is 0.05 divided by 2 is 0.025. Okay, so this area, this tail area is 0.025, this tail area is 0.025. Now in statistics, the level of confidence, C level, is given as 1 minus alpha. This is alpha. And that is the area in the center, 1 minus alpha. So the total area under the curve is 1, out of which area in the center is 1 minus alpha. That means area in two tails is alpha, because 1 minus alpha is in the center. Area of this tail plus this tail is alpha. Area in each tail is half of that is alpha by 2. So this is alpha by 2 area, 0.025 in this case. This is also alpha by 2. Because we are dealing with a standard normal curve, we know on the right of 0 it will be positive. So this particular value is called z alpha by 2 because it's on the right of the 0, it is positive. Same value on the left, but it is on the left of the mean, is minus z alpha by 2. So z alpha by 2 is critical value of z, plus minus I should say, critical value of z. Why, you ask? Because think about it. In the center is we are 95% confident that the population mean will fall. So we are less confident on the two tails. So the most probable region is in the center. Think of this boundary minus z alpha by 2. On the left of it, usually this is given by hatched area, is the least probable region for the population mean to fall. Same over here. Least probable region for the population mean to fall. Population mean 95% confidence will fall in the center. So these are called critical values of z. Why? Because this tail is least probable. Least probable for what? For the population mean to fall. And this is also least probable. Least. Okay. And the center is the most probable region where the population mean will fall. Hence, these two boundaries, minus z alpha by 2 and positive z alpha by 2, these are called critical values of z. Critical values of z. Okay. So, again, remember we are located z alpha by 2 on the right and minus z alpha by 2 on the left. Now, from this, we will derive the formula for minimum sample size. How so, you ask? Okay, so let's go to the other side of the board. Okay, so okay, this is the sampling distribution of x bar. Distribution of x bar. Okay, so already I told you from central limit theorem, the peak where the relative frequency is highest is equal to the mean of the population, and sigma x bar, standard deviation of this curve, sigma x bar, is sigma population standard deviation divided by square root of sample size. And remember, we have x bar on the horizontal axis. Okay. So, from central limit theorem we get this too. The advantage of this is now, in order to locate the population mean or make an estimate of the population mean, we will draw many samples of the same size n, okay, and calculate the sample mean for all these samples and then plot the x bar on the horizontal axis, and this is the relative frequency distribution of x bar. So where the peak is the highest is the population mean. Thus, we are getting an idea of the population mean without actually doing a census of the entire population. Now, suppose like we are 95% confident. So these are the two boundaries we discussed in the last diagram. Okay. And in the area in the center is 1 minus alpha. Okay, and area in each tail, we went over this before, is alpha by 2, because the total area under the curve is 1, out of which 1 minus alpha is in the center. Then the remaining area in two tails is alpha. That is divided into two equal parts. Why? Because of the symmetry. Okay, so we also told these are the critical values of the z critical values. Why? Because they divide the standard normal curve into two parts. In this case, on the left is the most probable region, on the right is the least probable region. Now C is the confidence level. It is the amount of confidence we have. Usually it's 95%. It is the amount of confidence we have in the method that we have used to determine the confidence interval. Okay, C is the confidence level, and alpha is sometimes called level of significance. And alpha is equal to 1 minus C. Okay. So confidence level is how much confidence we have in the method that we used, and 1 minus the confidence level is level of significance. Level of significance, as you will learn later in hypothesis testing, is the maximum risk we are taking in rejecting H0 when it is true. Maximum risk we are taking in making a wrong decision. Okay, so let's look at this curve. I already told you Z is a measurement, or as a measure of how many standard deviation you are away from the mean. How many standard deviations you are away from the mean. Okay, so this point is located Z alpha by 2 times sigma by square root of n away from the mean. And this point is located is minus Z alpha by 2 times sigma divided by square root of n. Okay. Why do I multiply by the standard deviation of this distribution? It's just like if you have a standard normal curve, the center, this is a Z curve, center Z is equal to 0, sigma is equal to 1. So if I am over here, okay, I am, whatever the Z value is, if it is Z alpha by 2 times 1, the standard deviation away from the mean, and if this is minus Z alpha by 2, then I minus Z alpha by 2 times 1 away from the mean. Positive on this side, negative on this side. So suppose I want to find the 95% confidence interval of the mean. Okay, so this is written as mu, okay, is equal to x bar, or mu is equal to x bar sample mean plus minus margin of error. M is the margin of error. Okay, and what is margin of error? Margin of error is the how many standard deviations you are away from the mean, is given as Z alpha by 2 multiplied by sigma divided by square root of n. Okay, how many standard deviations you are away from the mean multiplied by the standard deviation of the sampling distribution. Now this can be simplified if I square on both sides. M square is equal to Z alpha by 2 square multiplied by sigma square divided by square root of n times square root of n is n. Okay, so now I will multiply by n on both sides. N times m square is equal to Z alpha by 2 square times sigma square divided by n, and I have multiplied by n on left side, I will multiply by n on the right side. So This n cancels with this n, and I'm left with n times m square is equal to z alpha by 2 square times sigma square. Now I want to separate the n because my goal is to solve for the minimum sample size. Okay, so n divided by n on both sides, I get m square. Sorry, that's a mistake. I have to divide by, I'm separating out n, so I have to divide by m square on both sides. Okay, so that way n is equal to z alpha by 2 times sigma divided by margin of error square. So you ask me what is margin of error? Margin of error is the difference between sample mean minus the population mean. And this is m is margin of error. So you can see the utility of this formula. If we know the margin of error, that is how much distance between the sample mean and the population mean, that is your margin of error. If this is given to you and you are given the confidence interval, then you know z alpha by 2 multiplied by the standard deviation. Let's do a simple problem on this. Let us assume that margin of error, that is the difference between sample mean and the population mean, is 0.1. Okay, let's further assume that sigma is equal to 5. Okay, and let's assume 1 minus alpha, that is my confidence level, is C, is 0.95. Okay, in that case we can look up in the tables, or we can use our calculator. Z alpha by 2 is equal to 1.96. So n becomes equal to 1.96 times 5 divided by 0.1 square. Okay, so we can do an approximation calculation. If I, so this is almost equal to, if I make this 2 times 5 divided by 0.1 square, which is 10 divided by 0.1 square, or 100 square. So sample size is pretty large, is 100 and then 2 zeros, 10,000. Okay, this is of course a ballpark calculation, but you get the idea. If you're given the margin of error, the level of confidence, that is 1 minus alpha, you first figure out the z alpha by 2 from calculator or from tables, then multiplied by the given standard deviation divided by the margin of error, and then square. What people forget is to square. Do not forget to square this whole thing. That will give you the sample size, and we always round it up to the next higher number. But you saw how the formula has been derived. It is derived from the margin of error. Margin of error is the difference between the sample mean and the population mean. And the formula for margin of error, m. So this distance is actually m from here to here. Okay, and this m is z alpha by 2 times the standard deviation of the sampling distribution, which is sigma by square root of n. And basically then we do algebraic manipulation, we square both sides, then we divide by the square of the margin, and we get the sample size. I showed you an example too. I will stop here today. If you have any question, any comments, please do not hesitate to write me a note. Also, in your comment, if you like this video, please give me thumbs up. I really appreciate that. I really appreciate that. Okay? Because this will motivate me to produce more videos which are of interest to you. Okay? And if you like this video, please share with your friends. Please subscribe to my channel by hitting the red subscribe button. Okay? And also, please do not forget to click on the bell button because that will notify you every time I upload a new video. Thanks for watching. Okay, and please let me know where you are watching from. If you want me to show any other calculation also, please mention that to me. আপনারা যদি অন্য কোনো অঙ্ক আমাকে সলভ করতে বলেন সেটাও আমি করতে পারি যদি আপনি আমাকে জানান। ওকে, আর কোনো দ্বিধা নেই, কোনো প্রশ্ন থাকলে কমেন্টে লিখুন। প্লিজ রাইট মি আ নোট ইন কমেন্ট so that I know where you are from, and any question you have, I will be happy to answer. Okay, I will stop here today. Thanks for watching. Take care. Let me see what are the comment. Okay, great. I like the comments. Keep coming. Keep the comments coming. I appreciate that. Okay, thanks. Take care. Have a nice day. See you next time.